Hello engineers. Welcome back to CADMEC, where we simplify complex mechanical engineering concepts. What's the one thing that can make or break your product launch budget before you've sold a single unit? Tooling. Specifically, the injection mold. These molds can cost as much as a small house, but there are smart ways to slash that cost without sacrificing quality. Today, we're diving into cost reduction in injection mold design, strategies that can cut your tooling expenses by up to 50%. These aren't secrets, they're fundamental principles of good design for manufacturing. Mold making is expensive, but smart design can reduce costs while maintaining part quality. We'll dissect a plastic part design and uncover the hidden cost drivers. It's all about working smarter, not harder. I'll be your guide as we break down the key steps. Let's get started. First and most impactful, simplify your part geometry. Every extra curve, undercut, or intricate feature adds complexity and cost to the mold. Undercuts, like snap-fit clips or side holes, require moving parts in the mold, expensive and avoidable with smart design. Redesign features to eliminate undercuts and save thousands. Uniform wall thickness is crucial. Thick and thin sections cause sink marks and warping, leading to costly mold adjustments. Consistent walls mean better parts and simpler, cheaper molds. Analyze your design for thick spots. Core them out to match the rest. Ribs add strength, but keep them short and thick enough for easy molding. No more than 3 times their thickness. Deep, skinny ribs are hard to machine and mold, causing defects. Be ruthless. Ask if every feature is necessary or if a simpler shape will do. Eliminate unnecessary details that drive up machining costs. Every undercut you remove and every wall you make uniform puts money back in your pocket. Design with manufacturing in mind from the start. Simplicity equals savings. That's the foundation of cost-effective mold design. Next up, draft angles. They seem minor, but they're critical. Imagine pulling a straight-sided cup from sand, nearly impossible. Add a slight taper and it slides right out. That's what a draft angle does for molded parts. Without draft, parts stick to the mold, causing drag marks, damage, and production delays. 1 to 2 degrees of draft is standard. More is needed for textured surfaces. Forgetting draft means costly fixes or even remaking the mold. Proper draft ensures smooth ejection, faster cycles, and less wear on the mold. Use your CAD's draft analysis tool. Aim for all green surfaces. It's a 5-minute check that can save you 5-figure headaches. Draft isn't optional, it's essential. Add it early, not after the mold is cut. Make draft angles a habit in every design. It's a small detail with a huge impact on cost and manufacturability. Don't skip it. Let's talk about side actions, moving parts in the mold that create undercuts. Slides, cams, and lifters are engineering marvels, but they're expensive and high maintenance. Each side action adds complexity, machining, and assembly time. Costs multiply fast. A single slide can add 15 to 30% to your mold cost. A few can double it. They also wear out faster, causing downtime and expensive repairs. Always ask, is that undercut essential? Can you redesign to avoid it? Use pass-through cores or flexible tabs instead of features that require slides. Creative problem solving here saves big money. Minimize side actions for a simpler, more reliable, and cheaper mold. Scrutinize every feature. Eliminate unnecessary complexity. Great designers avoid side actions whenever possible. That's how you keep costs under control. Standardization is your secret weapon for saving money and time. Custom mold components are slow and expensive. Use off-the-shelf parts whenever possible. Standard mold bases from companies like DME or Husco are cheaper and faster than custom builds. Ejector pins, guide pillars, bushings, buy them standard, not custom. Designing for standard components means quick replacements and less downtime. Custom sizes require manual machining, adding cost with no benefit to your part. Even for part features, design for standard inserts and fasteners. Standardization speeds up production and maintenance. When a standard pin breaks, you're back up in a day. Custom parts mean long delays. Build your mold around what's readily available. Save money, reduce lead times, and make maintenance easy. Standardize wherever you can. It's a simple step with huge payoffs. Don't reinvent what already works. Now let's talk about runners, the channels that deliver molten plastic to your part. Cold runners are simple and cheap, but they create waste with every shot. Great for low volume runs, but material waste adds up fast in high volume production. Hot runners keep plastic molten all the way to the gate. No runner scrap, faster cycles. Hot runner molds cost much more upfront with heaters and controllers. But for millions of parts, the material and time savings pay off. The choice is a classic trade-off: low upfront cost and more waste, or higher investment and lower cost per part. Do the math. Calculate your break-even point. For cheap materials and small runs, cold runners win. For expensive plastics and big volumes, hot runners are the way to go. Match the runner system to your project's needs. Don't overspend on features you don't need. Make the right call for your production scale. That's smart engineering. Mold material choice is a major cost driver. Match it to your production needs. Aluminum molds are fast and cheap to machine, perfect for prototypes and low-volume runs. But they wear out quickly, good for a few thousand parts, not millions. Hardened tool steel molds are expensive and slow to make, but last for millions of cycles. They're essential for high-volume production and tough plastics. Pre-hardened steels like P20 offer a middle ground, affordable, durable, and good for medium runs. Don't over-specify. Choose the material that fits your volume and budget. Forecast your needs before you cut steel. The right material saves money now and later. Don't use a sledgehammer for a thumbtack. Pick the right tool for the job. That's how you maximize value. Tolerances. Engineers love them, but tight specs drive up costs fast. Every extra decimal means more precise machining, slower production, and higher inspection costs. Only apply tight tolerances where they're truly needed. Critical fits, seals, or safety features. For non-critical dimensions, use standard commercial tolerances. Over-tolerancing wastes money and slows down manufacturing. Work with your mold maker to identify which features need precision. Use tolerance stack-up analysis to focus on what matters. Most features can be looser without affecting function. Don't pay for unnecessary precision. Smart tolerancing is selective, not universal. Save money by relaxing specs where you can. Precision where it counts, nowhere else. Your mold isn't just a one-time investment, it's a long-term asset. High wear areas like gates and shutoffs will need maintenance. Design these as replaceable inserts, not part of the main mold block. When they wear out, swap them quickly. No need for expensive repairs or downtime. Modular inserts turn major repairs into routine maintenance. Plan for future changes by making likely to fail or update features into inserts. This flexibility saves time and money over the mold's life. Think like a maintenance tech, designed for easy service. Smart planning upfront pays off for years. There you have it, 8 strategies to slash injection mold costs. Simplify geometry, add draft, minimize side actions, standardize. Choose the right runner and material, apply tolerances wisely, and design for maintenance. It's about holistic, practical engineering from day one. Optimize in CAD to save thousands in tooling. Use these principles as your checklist for every project. Challenge every feature and plan for the tool's full life. Like, share, and subscribe for more CAD-MEC insights. Thanks for watching. See you next time.